Okay, so getting to the examples for 1.5. Example 1 talks about identifying angle pairs. So I'm going to name two angles, and you're going to tell me if the statement is true based on the two angles and the relationship I give you. So part A, BFD and CFD. And I'm going to use my pen to kind of trace the angles so that we can understand what's what. So BFD is this angle right here. Okay, that's BFD. CFD is this angle right here. Now, the thing about these two angles, I get that they do share a vertex. They do technically share a side, but their interiors overlap. So I would say that is false because their interiors overlap. Adjacent angles don't have overlapping interiors, okay? These angles, it's kind of funky, but they do share a side, they do share a vertex. They just can't share any points on their interior. So those angles would not be adjacent. Moving ahead to part B. AFB, EFD. So AFB, and I'm going to go to EFD. EFD. Now, if you look at these two angles, they do look like they might be. I'm going to trace this in red. If we look at this segment right here, or this ray and this ray, they do not form opposite rays. So I would say that one is also false. Okay, I get that they're opposite from each other when they're formed by different rays, but they're not formed by opposite rays. So I would say not formed by opposite. That's a really bad opposite rays. Okay, those aren't formed by opposite rays. So I'm going to erase that. And then finally part C, AFE, BFC. AFE, and I'll do BFC. And there's an easy way to prove if those are complementary or not. Think about 62 plus 28. That would be true. Because, in my explanation, I can just show the math here. 62 plus 28 equals 90. So those are complementary, because that's the definition of complementary. Moving on to example 2, making conclusions from a diagram. So some conclusions I can make, and this is the part where we're going to talk about some examples. So I'm going to look for a pair of adjacent angles, at least one, a pair of complementary angles, and a pair of supplementary angles. Okay. Also, there's a pair of congruent angles in there that I want to point out. So angles that are adjacent, angle 1, angle 2 would be an example of adjacent angles. All right. Also, angle 1 and angle 2 are congruent based on that marking. Now, I could go around the whole diagram and talk about all the adjacent angles or write them all out. I'll list them out, but I won't write them. Okay, so 1 and 2 are adjacent, 2 and 3 are adjacent, 3 and 4 are adjacent, 4 and 5, 5 and 1. They're all adjacent. Angles that share a vertex and a side, and their interiors are independent of each other. Okay. Now, if I'm looking at this and I'm looking for complementary angles, I'd have to see either a right angle symbol or two measures that add to equal 90. So really, I guess I jumped the gun there, but there's no complementary angles as far as I can see in that diagram. Okay. And then supplementary angles are angles that form a line or add to equal 180. There's no measures on here, so I'm going to look for angles that form a line. So that means I would say angle 4, and angle 5 form a line, and then angles, it looks like angles 3 and 4 form a line. Okay, so those are supplementary. So when I ask for information I can conclude, I'm looking for rock solid things that fit the definitions we covered earlier with the vocabulary. So I may ask for a certain amount, but just looking for those relationships. Now, I know I talked about a linear pair before, so this should kind of just be review a little bit, but adjacent angles whose non-common sides are opposite rays, basically they form a straight angle, right? And they're adjacent. So they're adjacent supplementary angles. That's pretty much it. That's all the definition of a linear pair is. So when you see a diagram like this and finding a missing angle measure, KPL and JPL, or KPL, JPL, are a linear pair, we don't have a measure to go off of. We can pretty much assume that these angles aren't congruent. So these angles are supplementary because they're a linear pair. So when two angles like that are represented with expressions, I would add these two angles together. 2x plus 24 plus 4x plus 36 equals 180. I'll write that better. Combine the like terms. 6x plus 60 equals 180. I can subtract 60 from both sides. 6x equals 120. I can divide both sides by 6. X is 20. One of the measures of KPL and JPL. And really, when you're writing these out, I really don't want you to just write the numbers for the measures. I do want you to write M, angle symbol, KPL. M, angle symbol, JPL. To show you mean measure of angle, KPL. Measure of angle, JPL. If I substitute 20 in to KPL, 20 times 2 is 40. 40 plus 24 is 64 degrees. For JPL, 4 times 20 is 80. 80 plus 36 is 116. So that's just me using mental math. Use a calculator if you need to, but just substituting in to find the measures of each of those angles, right? Moving on. Last kind of term we're going to learn here is an angle bisector, okay? So an angle bisector is mostly going to be a ray in our cases, all right? An angle bisector is a ray that divides the angle into two congruent angles. Splits the angle into two congruent angles, two angles of equal measure. Its endpoint is at the vertex of the angle, okay? So a segment could also be an angle bisector, but for the most part, we're going to see a ray as an angle bisector. So I'm going to draw a diagram to kind of illustrate this in example 4. But it says, ray AC bisects angle DAB. If DAC is 58, what is DAB? So what I want to draw is angle DAB. We're just going to draw an angle, and it's not going to be to scale, okay? It's not going to be the right measure. I'm just drawing it for an illustrative purpose here. DAB, okay? And AC bisects it. So that means that AC, a ray that starts at A and goes through C, bisects it. So what I want to show is that this, I'm going to use red, so it's different. This angle and this angle are congruent. The two angles that are created by that bisector are congruent. And it says if DAC is 58, what is DAB? So if DAC is 58, it's this little part right here. If this angle is 58 degrees, that means that CAB is 58 degrees because this angle is being bisected, it creates two equal measure angles. So the measure of DAB is just double the measure of 58. If I double the measure of 58, that's 116 degrees. Should have done that up top. Okay? Degrees. So it's understanding you're not given a diagram. You have to be able to draw a diagram and analyze that diagram to answer questions. That's what this example does. So now you should be ready to go on to the practice checkpoint, finish this lesson, and then you'll have a review and take our first quiz on 1.1 to 1.5 on Wednesday. Now, we got a lot of time on Wednesday to do the review and the quiz. I'll be opening up a Google Meet. I'll be helping you guys review stuff. I should have a pretty comprehensive review that's going to, if you do it right, if you do it the right way, you're going to be reviewed enough to be able to be successful on that quiz. So make sure you're checking Classroom every day this week to update things. Make sure you're emailing me with any questions you have. I'll reply as quick as I can, right? And if you need a Google Meet for anything, just let me know, okay? If you want a one-on-one Google Meet, we can do that. But I'll do an all-class one hopefully on Wednesday. I'm going to try and plan that for Wednesday. Other geometry class, Tuesday, Thursday. We can set one up if you guys need one.